hit and rebound collisions. Hit and rebound collisions use the formula, and so this is on page 2 of your data booklet in the top right-hand corner. Hit and rebound collisions look like this. M1 V1 plus M2 V2 is equal to M1 V1 plus M2 V2. And this side is before, and this side is after the collision. Now, we are going to be having direction for the first time. So before we start a problem, we've got to say one direction is positive and one direction is negative. Okay? All right, so let's try a problem, a hit and rebound collision problem. Okay? So you're running west and you collide with this guy called the Fridge. And the Fridge was this massive linebacker in the NFL. He was enormous. And he was roughly the same size as a fridge. So that's why they called him the Fridge. Anyway, so we were running at this guy and smashing into him and bouncing off of him. Just like somebody who's very large and somebody who's very small with exercise balls. Okay, let's write out a formula. M1 V1 plus M2 V2 is equal to M1 V1 plus M2 V2. Now, having a toolbox and planning ahead of time is a good idea. I'm going to do it for all of these questions. Now, remember, this is before the collision, and this is after. So in my toolbox, I'm going to be doing that as well. Okay. So before the collision, how much do you weigh? Well, you weigh, a very trim 30 kilograms. And before the collision, you're moving 3.5 meters per second. Now, let's take a second here. Let's say west is going to be a positive direction and east is going to be negative. Because we have two different directions, we need to figure out which one is going to be positive and negative. It doesn't really matter. The math will always check out, but I'm just going to always make west positive. Okay? All right. Now, the Fridge before weighed 180 kilograms. And wasn't moving. 0. Okay, that's going to be important when we start looking at the math. Now, after the collision, there's some things that aren't going to change. The masses aren't going to change. So the mass you were before the smash is 30. The velocity you're moving is now east, 2.5 meters per second east. So I need to say that's negative. The Fridge still weighs the same amount, 180 kilograms. And we don't know how fast the Fridge is moving. So what we're going to be trying to solve for is this variable right there, V2. Okay, let's put everything in, all our math in, and see how it checks out. Okay, so M1, 30 kilograms, V1, 3.5 meters per second. Okay, add that to 0 because that times itself is going to be 0. Because the velocity of the Fridge is 0 before. Mass 1, 30 kilograms. Okay. Times by speed after, negative 2.5 meters per second, right? Okay, so that's V1 after. And the Fridge still weighs 180 kilograms, and we don't know V2. Okay, so let's do the math first. We can, what we can do is we can multiply those two things out. So 30 times 3.5 gets me 30 times 3.5 gets me 105. The momentum is kilograms meters per second. Okay. And 30 times negative 2.5 gets me negative 75 kilograms meters per second. Okay. And we have 180 kilograms times V2. Perfect. Okay. Now, how do we solve for V2? Well, we have to get rid of this negative 75. So I'm going to add 75 kilograms meters per second. Okay, that cancels that out. What I do to one side, I have to do to the other. So I have to add 75 kilograms meters per second. So when I add that to the other side, 105 plus 75 gets me 180 kilograms meters per second is equal to 180 V2. Now, how do we get V2 by itself? Well, that's multiplication. So I'm going to divide this side by 180. What I do to one side, I have to do the other. Divide this side by 180. Okay, perfect. Just hide that. And that's kilograms. So kilograms cancel out. And look, I'm left with speed. And that gives me a perfect 1 meters per second. And what direction is the fridge going? Well, he's going west because we said a positive value is west. So the story of this is we have a giant guy and a little person, and the little person is booking it at the big guy who's not looking anywhere and smashing into the big guy and kind of making them stumble forward while the little guy explodes backwards. Bad news bears. Okay, let's try another problem. Same thing. Looks like the fridge. The fridge was on a diet. Fridge lost a little bit of weight. So we still have this rebound, but now the fridge is moving in the same direction that you are running at the fridge in. See how they're both west? Okay, so instead of the fridge not moving, now the fridge is. Okay, that's all right. We can still write out the formula. M1V1 plus M2V2 is equal to M1V1 plus M2V2. This is before, and this is after. All right, let's write down our toolbox. So, before. So, mass of you before was, what do you weigh? Oh, you still weigh 30 kilograms. Speed you're moving is west. Let's say west is positive, okay? You're running really fast at the fridge. You learned your lesson, 7.5 meters per second. Okay, the fridge weighs a little less than the last problem because that's a typo, but that's fine. And the fridge is also moving west at 1 meters per second. Now, after mass of you is the same, 30 kilograms, the velocity of you have exploded off the fridge east. So that's a negative value, negative 1.5 meters per second. The fridge's mass is still 120, but we don't know how fast the fridge is now moving. Okay. All right, let's put all of our numbers in there and see what we get. I'm not going to put the units in there because I'm going to run out of room. So mass before is 30, dot for multiplication. Velocity before, 7.5. Okay, add that to the fridge's mass before, 120, times by his speed or velocity, 1. So that's everything before. Mass of you after, still 30. And your speed is negative 1.5 because we've been going, we got to push the other way. Mass of the fridge is 120 V2. So we're going to do the same kind of thing. So we can solve everything on this side. 30 times 7.5 plus 120 times 1. We get 345. Okay. So the total momentum of the system before is 345, which means everything on the other side has to be 345. That's why we can make these systems equal to each other. Okay, 30 times negative 1.5 is negative 45. Okay, plus 120 V2. How do we get rid of a negative that's going through addition? We add 45. That cancels. Add 45. So 345 plus 45 gives me 390. And that equals 120 V2. Divide both sides by 120 because that's multiplication, right? Divide this side by 120. 390 divided by 120 gets me 3.25 meters per second. And because that's positive, we said west was positive. Okay. So you kind of made him move a little bit faster west than he was already going. So that is hit and rebound collisions. You should be able to work through a few of the problems on that worksheet now. If you haven't started that worksheet, pick away at it. We're going to be looking at explosions tomorrow, and then there'll be a day of review and catch up, and then the project will be due Friday. All right, thanks, guys.